And then when we watch these videos, we put it in 1.5 or 2 times speed.
Oh, me too. Me too. And it's so annoying.
Okay, good morning, everyone. Before we start, you guys put your questions on Bright Space. Not only Aaron, all of you. Just a reminder that exam 1 is next Friday. The exam will be at the testing center. It starts at 11, like regular time. You will be given 90 minutes to take the exam. You will not need more than that. And then, as a reminder, the exam will have no calculators and no notes. If there is any formula that you need, I will give it to you. But as far as you are concerned, then you cannot use any notes and any calculators. Okay, so you'll be at the testing center at 11, a little bit before 11, so they can let you all in. And that's it. Would you cover chapter section? Oh, okay. All right. So, yes, I will put a review. Thanks, Ibuka. I will put a review tonight. I'm working on it. Tonight you will have a review for the exam as well as the answer to the review. This will be put up definitely this evening. You will have it out there. Any other question? Okay. So let me go through your problems one by one. Okay, Aaron has number 49, ratio 35, and number 59. But this is section 6.3. Okay, all right, so we're gonna do that, and we have time. We start section 6.4 or 6.5, I forgot. Okay, so I start with number 35. I try to like to do them in order. So we have the following. We have the curve y equal x and y equal x to the power a third. We are in quadrant 1. Rotate about the x-axis. Okay, and the question is, they want us to use both the shell method and the washer method to find the volume obtained. All right, so first, let us graph it, and then let's see which one is easier. I will ask you this question. Probably they are the same, but I will ask you the question once I graph the function. So this is my function right here. And this is my axis of rotation. Y equal to x, straight line. X equal to third to 1/3 goes like this. Oh, sorry. My apology. Y equal to x equal to a third goes like that. Okay, that's x equal a third. So I'm only interested in the first quadrant, so I can erase this piece right there. I don't really need it. So these are the two curves I'm interested in. And the intersection point, now obviously they intersect at 1. let us say we didn't see it, which is I hope all of us see it. We set those equal to each other. And then because I have a cubic root, I have to raise both to the power 3 to be able to solve. And then this would give me, we have to set it equal to 0 to solve. We factor equal to 0. And then this will give me x equal to 0. And x is plus or minus 1. The minus 1 is the one in this quadrant, and that's really what we want. As I said, we knew that, but just in case it's not very clear. Okay, so now they want us to do it around the x-axis. Do you think any of them is easier, shell or washer? Do you have any preference? Does it matter? What do you think? Washer? Okay, let's try to do the washer. So the washer is, so this is my one, my axis of rotation. The washer means you have to take those slices which are absolutely perpendicular to the x-axis. And we don't have any issue. If I took my slice here, the outer and the inner will have basically the same formula. I don't really have issues with that. So this is my xi. You can use either end to put it xi. Doesn't really matter. Okay, so we're using the washer first. The slices are perpendicular to the axis of rotation. Okay, all right, so we need the inner and the outer. So basically in our mind, when we rotate this, we're getting this piece, that's the inner, and the outer is gonna go like that. So this is the inner and the outer. So the inner is from here to here, that's my inner. And my outer is from my axis of rotation that's crucial to the outer curve. So that's my axis of rotation to the outer curve. That's the outer radius. So typical washer. We go through everything. The inner is going from here up to here. It means in this case, x is the variable. I know my x, I need my y, and this is y equal x. My outer is, again, I know my x. I want the distance, the vertical distance from the x-axis all the way to this curve. So this is the square root, no, I meant the cubic root of x. Now the thickness, sorry, the height, that's a washer, is the little delta x. And the volume of a washer is pi times the delta x. This is usually area of the base of the washer, which is the outer square minus the inner square. The outer is xi to the power a third. The inner is xi. Once you reach this stage, my opinion, the problem is really falling apart very easily. So the volume is going to be the integral from 0 to 1 of pi times the x, which make it a volume, and this is the base. So pi times x to the power a third squared minus x squared, which means pi times, now I simplify and then I integrate, which is a very easy integral. X third to the power a half, we multiply the power, give me x to the power 2/3 minus x squared. So finally, this is equal to pi times 1 over 2/3 plus 1, which give me 5/3, so it's 3/5, x to the power 5/3 minus a third x cubed between 0 and 1. Okay, so which will give me pi times 3/5 minus a third, which is very easily pi times, that's a 15, and that's 9 minus 5, which is 4. All right. Now let's do the shell method and then we proceed. Question?
Professor Elias,
Yes, go ahead, Rocco.
wouldn't it be 2 pi? Or am I misremembering for the washer method?
Oh, pi.
Just pi? Okay,
Yes,
so pi for the
yes,
washer,
yeah.
2 pi
Remember,
for the shell.
To help you remember, what's the area of a circle?
What's
Pi
that?
times the radius square.
Okay.
And
Hmm.
that's exactly where it's coming from.
I see. Okay. My
Okay,
mistake.
so yes. So when I say area of the base, basically, this is my washer right here. Okay, that's the outer, and that's here we have the inner right there, kind of. Okay, so the area of the base, it means the area of this here, and this is the height. That's really what the volume is. So the base is basically, you can think of it as a circle with a hole in it. So its area is going to be the area of the big circle, which is the outer square, minus the area of the little circle. It means pi times this minus that. And to get the volume, you're multiplying it by this delta x right there. Otherwise, it's just an area. That's where the importance of the delta x. Otherwise, you will be adding area, which doesn't, you add volume to get the volume. All right? Okay, so now we're going to do the shell method for the same problem, which is a good review for you. So the shell. Okay. So the shell is, of course, I have to go back and graph it. So I have the line and I have the curve, which go like this. That's x cubed. And this is 1 here. This is 1. That's what I had so far. And this is the x-axis. Now, if I want the shell method, it means I need those slices parallel to the axis of rotation. So the minute I'm taking those slices, it means y is my variable. So now I am definitely interested in that number right here. Now, when I rotate this, even if you rotate it a little bit in your mind, you're not going to get a washer anymore. You're going to get basically a cylinder where the boundary of it are very, very thick. That's really what you're getting. Okay. So now for the shell here, what I need, so y is the variable, and that's crucial. Y is the variable. Everything has to be done in terms of y. So let me call this yi, because in my mind, I'm cutting this into pieces and finding the volume obtained by rotating every little piece. That's really what in our mind. So now a typical shell. Typical. For a shell, I need the radius. I need 2 pi times the radius times the height times the thickness. I need every aspect of that. And finally, I need the volume, which is once we find the little pieces, the volume will be easy. Because remember, that's where the 2 pi is. It's 2 pi times the radius, that's for the washer, times the height, times the thickness. Okay, and now let us go through every one of them. What is the radius? It's from axis of rotation, which is the x-axis, all the way to here. Remember, y is the variable, not x. So the axis, the radius here is the yi. That's my radius. What is the height? The height is from here to here. So in this situation, the way you think about it is that you know how much you have from here. That's what's given to you. That's basically what's given, and you're finding everything in terms of it. That's what's given to you. So the radius is gonna be whatever given to you, which is the y. The height is from here to here. So to find the height, I need this horizontal distance. The minute I need horizontal distance, it means I need the x that correspond to this y. So I need to solve for x. This is x equal y, so nothing changed. Right here, I need to solve for it. This is y equal x to the power a third. To solve for x, I need to raise both to the power 3. It means x is y to the power 3. Okay? So what is going to be the height? The left value, the right, which is yi minus the left. The left is yi cube. Please, if you have any questions, make sure you ask. The thickness of the shell is this little bit of delta y. So finally, what is the volume? The volume is 2 pi times the radius is the y. The height is yi minus yi cube, and the thickness is the delta y. So finally, the volume is the integral. Now I go back and I see which interval I should cut into pieces. The interval from 0 all the way to here. This happened to be 1. It doesn't have to be 1. So integral from 0 to 1 of 2 pi y minus y cube dy. So finally, I will get 2 pi. And we should get exactly the same answer we got before, unless I did a stupid mistake along the way and you guys did not correct me. Minus that. So this would give me 2 pi from 0 to 1, and I have to move to a pencil because I do mistakes. 1/3 y cube minus 1/5 y5. So finally, this would give me 2 pi times 1/3 minus 1/5, which would give me 2 pi. 5 minus 3 times 2 over 15, which is 4 pi over 15, which is exactly what we got prior to that. All right? Is this problem clear? Any question about it? So you always focus. What's your variable? If you are cutting the interval on the x-axis, x is the variable, everything in terms of x. If you feel you need to cut the interval on the y-axis, y is the variable, everything in terms of y. Questions before I move on to Aaron's question, which was for 49.
Can you repeat what you said about the axes?
Yes, you have to decide which is your variable, x or y, all right? So when in this scenario, when we use the shell method, you are taking those horizontal slices. It means you need to cut the interval on the y-axis into pieces to cover this with those slices. Y is your variable, everything in terms of y. In the washer method, to cover the region with those vertical slices, you have to cut the interval on the x-axis into pieces. X is your variable. In this case, everything in terms of x.
So in a situation where either works, is it up to us to just
Yes,
choose which one we
absolutely.
use?
Like in your quiz today, some of them I told you what to use, and one of them I told you, you guys use whatever you think is better. Did I answer your question?
Yeah, that makes sense. Thank you.
Yeah. One of them I told you use whatever you think is better, and the others I told you, use this method because I want to make sure you guys know all of them. Okay, so let's look at number 49. Did I assign 49? Seems so. All right, let R be the region bounded by the upper half of the circle. So we have the following circle, x squared equal r squared. That's a general equation of a circle that I mentioned it last time, and I think you should internalize this equation. When I mean internalize it, you have to know it because it's a basic equation. And by the upper half and the x-axis, so that's here. The upper half of the circle, it means that's the piece right there, and the x-axis. So this should be r, and this is minus r, and this is r. Okay, that's the picture we have. A sphere of radius r is obtained by revolving about the x-axis. Actually, we knew that when we revolve about the x-axis, this is going to generate a sphere. And that's something we've touched upon it before. Question number 1. Use the shell method to verify that the volume of the sphere is 4/3 pi r cubed. So they want us to verify this formula. So they did not give us a specific radius. They want us to work with radius in general. And they want us to use the shell method. Okay, so the shell. Okay. So the shell method, it means we have to take slices parallel to the axis of rotation. So this is my yi here. And this is my piece. Okay, and this is the one I need to rotate about the x-axis. Okay, that's a typical slide. Because they want the shell method, it means parallel to the y-axis. So what's my variable in this problem immediately? What's the variable immediately?
X,
No,
Y.
y. Of course, if it's not x, it's gonna be y. Why, not x? Which interval, if you wanna cover this with those slices, okay? Which interval you have to cut the pieces? You're not cutting it like this. You're not cutting them vertically. You're cutting them horizontally. It means y is your variable. So, variable y. Okay. All right, so now what I need is the radius, the height, and the other stuff, which the thickness is easy, and the volume. So in your mind here, I know this. I know the yi. Everything you have to express it in terms of the yi. Since the axis of rotation is the x-axis, this is the radius, which is the distance from the center, which is right here, all the way to the edge of the cylinder. That's the radius of my shell. Sorry. It's yi. Now the height of my shell. To find the height, I have to find the horizontal distance. Basically, because of symmetry, if I find the horizontal distance from here to here, times it by 2, I get the whole height. The height is from here to here. Okay, so if I know this piece, I multiply it by 2. But now what is this piece? I need to find this in terms of y, but I know that. I know that x squared plus y squared equal r squared. It means x is the square root plus or minus the square root of r squared minus y squared. I know the y is the x I'm interested in. So now we have an issue, but it's not really a big deal. This piece right there, the red piece, is the positive square root. And the other one that I'm going to highlight it in this is the negative square root. Okay, because x is negative here. But we're not gonna give ourselves a headache. We're gonna say that the height is 2 times, because that's a circle, 2 times the positive one, 2 times the square root of r squared minus that. I stop a minute to see if you guys have any question, because the rest is easy. This is multiply. This is multiply. Please go ahead.
Where'd you get the 2 from again? I missed that.
Look at the picture.
Okay, I'm looking.
This piece is from where to where? This is your yi.
Yes.
The x is this,
Mm-hmm.
the positive square root.
Yep.
And the x here is minus, because x is positive here, x is negative here. So it's not the same formula. But
I Okay.
All right? Please, all of you. So if this is my y, this green wiggly sign is the positive square root. I multiplied it by 2 to get the whole height because of the symmetry of the picture.
Okay, interesting. All right.
Otherwise, you will have to take the right minus the left.
Oh,
But if you do
okay.
that, you will get exactly the same. Because
Okay.
the right is the square root of r squared minus y squared. And the left is minus that. If you combine them, you will get 2 times this. So you can either do right minus left, once we figure out the equation, which is correct, or you can say, you know, there is a symmetry in the picture, that's a circle, and we understand it. I find the length from here to here, I multiplied it by 2, I get the whole height. I stop right there for you guys to understand the picture. Anybody has questions beside Rocco, which always ask good questions?
Can you explain the radius again?
Okay. Let me move this a little bit. Suppose here I have whatever, a circle, and let us say the radius is 4. Okay? And I take a piece here, let us say this is 1. And I take this to be very, very, very small. Are you with me? I rotate this. Forget about the thickness, totally. I rotate this. So that's my cylinder. Do you see it? Okay. What's the radius of the cylinder?
1.
1. Understand that? Does this make sense?
Yeah.
Okay, now, what if I take another one? Because that's really what I am doing in my mind. Suppose I take, so this is my yi in this scenario. Suppose I take this to be a half. And I do the same. I take the slice, forget about the thickness. The thickness is not a big deal here. And I rotate. What's going to be the radius here?
A half.
A half. That's the yi. The yi is changing. That's the yi. From here to here, that's the yi. From here to here, that's the yi. And I keep playing the same game. If I take, for example, 3 here, and I do that circle. So that's the axis of rotation. And that's the 3. What's going to be the radius? From here to here. That's going to be the radius. What's going to be the height? From here to here. So the radius is always the y. The height is this horizontal distance between the 2 curves. Go back to here. Is this the same picture? The yi is changing because the way we're thinking about it, the way really we're thinking about it is we are taking this, and so whatever the region is, and basically we're cutting this into pieces and we're rotating. And then another, so that's one shell. And then I'm doing again, I'm taking another shell and I am rotating. So that's really what's going on in my mind. So I'm taking another little piece here. That's another shell, and I am rotating. So I'm putting a shell within a shell. That's how I am covering my region. Then, so this is the first one, and then I keep doing this. So that was the first shell I got. And then that's the second shell. And then I'm doing again, I'm taking another piece here, another rectangle. So definitely the radius is changing, and I am rotating that piece. So I'm putting a shell within a shell within a shell. So it looks like we have here a piece of log with different generation in it. So it's a shell without a shell. I'm finding the volume of each one of them. And the radius is exactly the distance from here to here, the yi. Questions? Okay. The thickness is the delta y, and the volume is 2 pi yi square root of that times the delta y. So finally, the whole volume is going to be the integral of 2 pi y square root of r square minus y square dy. What are going to be the limit
Professor,
of integration? Yes.
what happened to the 2 times the r squared minus y squared in the height? Where did that go?
2 times what?
In the height, it's 2 times r squared
Ooh,
minus y squared.
ooh, ooh, ooh. You're absolutely correct. My apology. Thank you. All right. What are the limit? What are the limit of integration?
Is it 0 to
0
r?
to r.
Absolutely 0 to r. Now the problem is practically done. 2 and 2 would give me 4 pi. Integral from 0 to r. Don't let r scares you at all. R squared minus y squared dy. How would you solve this integral? Very quickly, you have to start the quiz. How would you solve this integral? Quickly.
Substitution.
You have no other way out. Du is minus 2y dy. So it's not really hard. So this will give me the integral. If y is 0, u is r squared. If y is r, u is 0. And then this would be my u to the power a half. The y dy is minus that du. So I will have minus 2 pi times 2/3 u to the power 3/2 between r squared and 0. So finally, I will get minus 4 pi over 3 times 0 minus, if I put r squared to the power 3/2. So finally, I will get r squared to the 3/2 is r cubed. I will get 4 pi over 3 r to the power 3. End of the problem. Okay.
That's pretty cool.
All right, so please go over it. And I will assign the disk one because the problem have part B. I will assign it one more time. So you guys will actually be able to work with those ideas. Okay, so the quiz on bright space, as you guys know, please get started. And everybody's doing PDF. Please make sure you do it PDF. Otherwise, I cannot grade you. I cannot do anything. Okay, so good luck. And I'm with you as usual.